So is RAG dead? This is a question I keep hearing multiple times. And this specific time, people are asking about it because what Google just released, which is Gemini Embedding 2 API. This is Google's first fully multimodal embedding model built on the Gemini architecture. But what it does is an industry first. It takes text, images, video, audio, and documents and maps all of them into a single unified embedding space over 100 languages. And it's just not for search. Think of RAG, semantic search, sentiment analysis, clustering, all of it becoming multimodal in nature. Now, if you are building RAG systems right now, this changes the entire retrieval layer. Doesn't kill it, but it changes it significantly. And today, I'm going to show you exactly what that means. I built a full working application using the actual Gemini Embedding 2 API, and I'm going to show you the actual embeddings, the actual vectors, the actual math behind it. Before we get into it, a real quick disclaimer, all opinions are my own and do not belong to my employer. With that, let's see the app live. So here is the application that I created. We will look into it in two different parts. One part, we will try and use this to understand embeddings in detail. And then the second part is where we will look into the practical application of embeddings. So let's start with the most important concept, which is what is actually an embedding. So, an embedding can take a piece of content. In this case, it can take text or an image or an audio, and it will convert it into a list of numbers, which are also called as vectors, because these are represented in a multi-dimensional space. Let's see this in action, right? So here I have an input, which is wireless Bluetooth earbuds, and then input B. What I'm trying to do is I will be creating a embedding live for both of these. So you can see for vector A, which is wireless Bluetooth earbuds, this is the embedding, which is 3072 numbers each. And then this is vector B, which represents cordless headphones. Now, you know that earbuds and headphones are quite similar. So this is how, when you're converting it into vectors, you're comparing the vectors in the embedding space. And if they are similar in nature, then you will find a similarity match, right? And these vectors actually capture the semantics or the meaning of it. Now, we can also do something in images. So for example, here, I'm going to upload, let's say this headphone here, and then I'm also going to upload something else, let's say earbuds. Now, if I'm going to click on generate and compare, again, it's going to say that, okay, it is similar match. Now, what I can do is I can go back and say that now, let's say like a laptop stand. Now, if I click on generate and compare, you will see that it is going to say that it is very different and it has given a negative score. Also, you can do this exact same thing for audio analysis. So if I click on this, hi, how are you doing? And I will do an input recording B. Hi, how are you? So now if I do a comparison, it is going to generate the embeddings. And again, it is a similar match, right? So what you just saw live in action is how we are able to create a multimodal embedding for all of these three different types of input. And I was able to do that using a single embeddings API. And that's what is possible now with this option. Now, let's try and understand this a little bit more in detail, right? So, in the legacy architecture, you will have to use different models to create an embedding for unstructured text, as well as for images or for videos. And then it becomes a little bit difficult for you to use this for a modern architecture. Now, if you look at what the new solution does is it is able to, as we just saw in the demo, it is able to use just one API and is able to convert all different formats in a unified vector space. So what that allows is it allows us to not only search for text in a text mode, but you can also go ahead and search for photos while tapping the text, and it should be able to answer that for you as well. So it's pretty fascinating from that perspective. Some of the new capabilities that this allows is, as I was saying, interleaved input, which is you can actually pass a sequence of text and images seamlessly, and the model will natively process the sequences, etc., which is very interesting. Then it also does specialized task types. So this one is particularly very interesting because usually what happens is you can now tell that, hey, this is for retrieval and this is for query. So when you go on your search box on any kind of e-commerce website, and we'll look into the demo very quickly here on the catalog and embed. But when you type something on the search box, that is the query, right? So you need to create the embeddings for the query first, and then you need to retrieve the existing embeddings. Earlier, both of them will be in the same task, but now because of this new API, you have two different tasks available. That way, it is able to optimize the vectors for asymmetrical semantic search, which is pretty cool. So that's another interesting one. So this is the Matryoshka dimensions, which allows you to actually further compress from 307 dimensional vector down to 256 dimensional, saving up to 90% in database cost, which is again like a fantastic thing. We also are able to now support native audio injection. So that means, and I showed you the demo as I was speaking, right? So you're able to natively have an audio as an input and you're able to do a compare and contrast. The last one is multi-page PDF and OCR, which is fantastic because now OCR is built natively out of the box. So it will not only be able to read the text when you provide PDF, but it will also be able to understand the images and all of those things which are part of your PDF. So these are some of the interesting things that are available directly out of the box when it comes to the Gemini embedding 2, which I thought is fascinating, right? This is definitely an industry first, and you should be able to see that in action now. So now that we have understood what embeddings are, what vectors are, and what are the different possibilities out there with Gemini embeddings 2, let's actually explore the use case, right? So this is what I was showing you earlier. So these are all different products. So I created the products and I also created the description for the product so you can see the name, etc. Right. So what I'm going to do here is I'm going to initialize the generate embeddings. So now you're seeing that it is able to generate the embeddings pretty quickly, and you're seeing text, image, and combined vectors being created. So there were 20 images, and you can see that for each one of this, I have now the text vector, image vector, and the combined vector. So I can look into any one of these images, and you will see that you have all of these things over here, right? So that's the idea. Once you have converted this into embeddings, what you're able to do now is basically do different activities, right? So the most obvious one is search. So let's say that I'm looking at wireless headphones. So if I click on this, then what it is going to do is it is going to then use this and convert this into embeddings live. And then now it is going to do the comparison, vector comparison, right? So you can see that here it is able to identify which one is the right one. It is also like explaining the similarity from a cosine perspective, the scores, etc. And it is ranking in reverse order, right? So this is fantastic because you're able to now see in live action how this works. You can do the exact same thing. You can basically, let's say that I select, let's say this one, and then if I execute the vector search, it is able to then again convert this live into embedding. This is the query embedding as we discussed earlier. And then now it is going to look for vector comparison for each one of these, right? And you're able to see how that does. Okay, now let's look at the third modality, which is audio. So let's say that I say floor lamp, right? Okay, so now let's execute the vector search here. And you would see that, okay, the first step again, it's I'm doing the query embedding. And then here is able to basically look at the LED desk lamp. So this is the closest to the products that I had uploaded, and you are able to see that it has found that, right? So this is something which is now possible because of Gemini embedding 2. The other cool thing is it is also able to decrease the embedding size from 307 dimensions to very less number of dimensions, which I mentioned earlier. And that way, what it is also helping is if you had 10 million products with 307 dimensions, it will probably calculate around 114 GB of vector database. But now with less number of dimensions, which is 256, you are compressing it to 9.5 gigabytes, right? So this is fantastic when it comes to embedding, and you're able to use this. So these are some of the very interesting real use cases of what embeddings 2 is all about. And you're able to see how this is actually going to revolutionize. When you think of RAG, right? Obviously, the implications, the usage of embeddings 2 is beyond RAG. But even with RAG, right? Earlier, what you will have to do is you will have to create the retrieval for each one of the data sources separately using separate models. Now this basically streamlines it, and you are able to achieve that architectural optimization very easily. And that's the idea. So it is not going to kill RAG, but it is going to make it much more optimal. It is going to make it much more better. And it is going to change the R of RAG, which is the retrieval side of the house. So that is what I wanted to cover today. If you guys have any questions, as always, please let me know in the comment section. I hope this was helpful. This is brand new feature. Go ahead and try it. I'll list down the documentation which is available, via which I was able to build. So I used anti-gravity to build this particular demo. You can see that I have used the Gemini embedding preview model over here. And if you see, like here, I'm using and calling this particular model when I was retrieving, right? So I was able to build this entire application using the actual API, and which was a lot of fun. Please go ahead and try it out. I'll leave some of the documentation links in the description so that you can also give it a shot. And as always, if you enjoyed the video, please hit that like button. Let me know in the comment section. And if you're new here, please do hit that subscribe button as well so that you can keep getting these kind of educational videos. Thank you very much for your time. Thank you for watching, and I will see you in the next one.